Hey, welcome to 4.4. We're just going through some definitions right now just so we can kind of talk about this stuff without having to do it in class. So let's just start off by talking about transformations. We've been doing translations already, and so we're going to talk about transformations because translations are a specific type of transformations. Alright, so a transformation is a change in size or position of a figure or graph. So we move things left or right, but we haven't really done anything else. So what I want to do quick is just to show you just some examples of if we have a quadratic, what can I do to kind of change some things around? Alright, so if you see y equals a parentheses x minus b squared plus c, we can kind of see if I change b, if I just move b, all we're doing is moving the graph left or right, right? So that's just going to translate the thing left or right. And then if we look at c, that's the number out here, that's going to be moving it up or down. So we can move our graph up, we can move it back down, and so that's going to help us move our graph translations, right? So we can do both of them at the same time. Ooh, look at that. It's actually just going to be kind of diagonal. Look, it's kind of bounces around like those old-time DVD players, right? So those things are just going to help us move it diagonally. But what happens about this 8? What does that do? So if I just move that, look what happens. It goes negative, and then it goes around, it gets wider, and it gets skinnier, all right? So there is something else that happens, and that this A value, changing this A value, also starts to transform our graph. Alright, so it's a transformation. It's not translation, it's a transformation. Okay, so those are some transformations. Change in size or position. We can change the size, we can change the position. So specifically we're going to start to talk about quadratics. So a parabola is the shape of the graph of the quadratic. So if we look at this thing is called a parabola. Alright, it's a quadratic, it's x squared, y equals x squared plus some other stuff. But the shape of this graph, this U shape, is a parabola. All right. The line of symmetry is the vertical line that passes through the parabolas. I guess that should probably be there we go. The parabola's vertex. All right. And we say, what's a vertex? So we're kind of going to explain both of these at the same time. So the vertex is either the maximum if the graph opens down, or the minimum if the graph opens up. So we look at our graph. This one opens up. See how it's kind of opening up this way? That means this point down here is the vertex. That's going to be the minimum, and the line that passes through this thing right here, we just say x equals c. No, x equals b. There we go. And let's just change this color. Maybe we can change that. Oh, we can't change the color. Okay, so x equals b. So as I move this thing around, that line of symmetry is always passing through here. So that is the b value. All right, even if I move it up or down, that b value doesn't change if I change this a, if I make it kind of skinnier or wider. That also doesn't change the line of symmetry. And the line of symmetry really says if I pick any point on here, if I go 3 to the left, I also go 3 to the right, I will hit the parabola. There'll be a point on the parabola. If I'm here, I can go 4.5 to the left, 4.5 to the right, it'll be on the parabola. Alright, so this line of symmetry says if I could fold the parabola along this line, it'll match up perfectly this side and this side. Alright, so the line of symmetry, it's symmetrical. It passes through the vertex, and the easiest way to write that is just x equals b. Whatever this b value is, that's the line of symmetry. Alright? Alright, so we have line of symmetry, and the maximum if it opens down, minimum if it opens up. So we have this one opening up. This point is going to be the minimum. It's the lowest that we can get to. Now if we change this a to say, oh, there we go. Now our graph is opening up. Or I'm sorry, our graph was opening up. Now it's opening down. So if it's opening down, this becomes the maximum value, the highest point that we get, and then starts to go back down. So the vertex is either the maximum or the minimum, depending on if it opens down like this one, or if it opens up like that one. All right. Then let's go down here to parent function. So a parent function is the function that is the building block of all other functions that are like it. For example, y equals x squared. Okay, so y equals x squared is just the parent function. That would mean if we go back to this thing and we just get rid of the a and the b and the c. So if I just get rid of those real quick and I just delete them. This is going to be the parent function right here. Okay, so we can get rid of a and b and c. And if we don't have them anymore, that is our graph. Okay, there is our parent function. Everything else, every other parabola that I want to create, can be just a difference of this one. I can change the a to make it go up and down. I can move it, shift it left. I can shift it right. I can do whatever I want to this original parent function to get any other function. That's the family of functions. The family functions are all of the functions that can be transformed from the parent function. So anything else that is a quadratic, I can get by transforming it horizontally, vertically, or doing something to the how wide it is opening. All right. And then lastly, quadratic functions. Quadratic functions are all the functions created from the transformations of the function y equals x squared, because the highest power of x is squared. All right, so these are all considered quadratic. So I could have like y equals x minus 3 squared plus 7. That is a quadratic, because the highest power of x is going to be a square. All right, so there are some quick definitions. Thanks for taking notes. I'll see you soon.